This is exercise 14D, question 15. And the question says, a player throws a die whose faces are numbered 1 to 6. If the player obtains a 6, she throws the die a second time. And in this case, her score is the sum of 6 and the second number. Otherwise, her score is the number first obtained. The player has no more than 2 throws. Let x be the random variable denoting the player's score. Write down the probability distribution of x and then determine the mean of x. Well, the problem with this question, like with many probability questions, is to work out exactly what's happening. What's happening is the player is going to get a score, and the score will be different depending on what the first number is. If the player throws a number 1 or a 2 or 3 or a 4 or a 5, that's her score. If she throws a 6, she then throws the dice a second time, and then she will get another 1 or 2 or 3 or 5 or 6, and her score then will be 7 or 8 or 9 or 10 or 11 or 12. So one can represent this situation in a tree diagram. It's going to be a funny looking tree diagram because on the first throw there will be 6 options. But then if she throws a 6, there'll be another 6 options. So that'll be the shape of the tree diagram, and these will be the outcomes. 3, 4 and 5. Now if she throws a 6, she then has another go, and she might get a 1 on the second go, in which case the total will be 7, or 8, or 9, or 10, or 11, or 12. Now those 11 things we've put there, that's numbers 1 to 12, without the number 6, each have a probability, and we can work out from the tree diagram what that probability is. Well, on the first throw, there's a 1 out of 6 chance of getting any of these numbers. So each one of these numbers has a probability of 1 out of 6. Now on the second throw, there's also a 1 out of 6 chance for each one, and I'm running out of room here so I won't be able to fit them all in. But each one of these throws in the second corner, the second option here, also is 1 out of 6. Which means the probability for each of these endpoints, here, will be 1/6 times 1/6, which makes 1 over 36. So each one of these will have a probability of 1 out of 36. So now we know what the probability distribution looks like, because we have 11 possible outcomes. The probability for these first 5 is 1 out of 6. The probability for these last 6 is 1 out of 36. You'll notice that 5 times 1 out of 6 plus 6 times 1 over 36 equals 1, which is what we would expect, because these 11 are indeed all the possible outcomes. So the probability of each of them added together must indeed equal 1. So we're now ready to create the probability distribution chart, and it's going to look like this. So the possible outcomes are 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. Those are all the x's, and the probability of x is 1 on 6, 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 1 on 36, 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 and 1 on 36. And then to find the expected value of x, it's going to be the sum of all the 1 times the 6, plus 2 times the 6, plus 3 times the 6, plus 4 times the 6, plus 5 times the 6, plus 7 times the 36, plus 8 times the 36, etc., plus 12 times the 36, which equals 15 on 6 plus 57 on 36, which equals 147 on 36.